In this video, I'll be talking about analysis of variance. Analysis of variance, or ANOVA, can be used to compare the means of more than two groups. For example, does the choice of ice cream flavor affect the average daily number of cones sold at a certain ice cream shop? Say we wanted to compare the average daily number of cones sold between three flavors: strawberry, vanilla, and chocolate. You might ask yourself, if we're comparing means, why is it called analysis of variance? Suppose that on average we sold 40 strawberry, 50 chocolate, and 60 vanilla cones daily. Are these numbers close together or not? It's hard to tell by just comparing the averages alone. Taking into account the variability allows us to see whether these means are significantly different or not. For example, in the plot on the left, the variability is higher and there's a lot of overlap amongst the three flavors. Whereas on the right, there is lower variability within each group, and the differences in the three group mean flavors look more distinct. So in this video, we'll be focusing on one-way ANOVA, which compares group means of a response across a single categorical variable. The null hypothesis is that all group means are equal, and the alternative is that not all group means are equal. This doesn't necessarily mean that all group means are different, just that at least two means are different. The variability can be represented by something called the sum of squares, which can be broken down into two parts: the treatment sum of squares, SST, which represents the variability between the groups, and the error sum of squares, SSE, which represents the variability within groups. Together, they give us the total sum of squares. Well, we won't get into too many details of the formulas in this video. This is called the ANOVA identity, and it's very useful. The test statistic F0 is a ratio of the between group variability and the within group variability. So this test is significant when there is much more variation between groups than within groups. The between group variability is computed as the treatment mean square, MST, which is the ratio of the treatment sum of squares over its degrees of freedom. Similarly, the within group variability is computed as the error mean square, MSE, which is the ratio of the error sum of squares over its degrees of freedom. Under the null hypothesis, this test statistic follows an F distribution with degrees of freedom k-1 and n-k, where k is the number of groups we're comparing, in our case 3, and n is the total sample size. Now, this might seem like a lot of information, but thankfully we can conveniently organize all of it into an ANOVA table. So if our p-value is less than our significance level, we have sufficient evidence to conclude that not all group means are equal. In our example, this would mean that the average daily cone sales are not all the same for each flavor: strawberry, vanilla, and chocolate. Now, after getting a significant result, you might wonder which group means are different. That leads to a concept called post hoc testing, which won't be covered in today's lesson, but it's an important next step in the statistical analysis.